Hi, math fans. In this video, MAT120 Intermediate Algebra, we're going to discuss section 5.3, which has to do with division of polynomials. Okay, so we're going to show you three ways to divide that are that we commonly use. Okay, the first one is, say we have this problem right here. This is an example one in your book, but just go over it quick. Suppose we had 12x to the third plus 8x to the second plus x plus 4, and we wanted to divide this by 4x. Dividing by a binomial factor like this is almost like factoring out, but it's not quite the same thing because you could not factor out a 4x out of here. You can't really take an x term out of everything, and you can't take a 4 out of everything, but we're going to try to take out a 4x. And the way we do it is quite simple. All we're going to do is under each one of these terms, we're going to take each one of these terms and divide it by 4x. So 4x becomes the denominator of each one of these terms. Let's cross this off. And that's how we divide it. Okay, so how do you divide using powers and numbers? Well, you divide the big numbers and you subtract the powers. If it doesn't have a power, it's 1. Divide, subtract. Pretty easy, huh? X1 or just X. Here, you can't really divide very well, so we're going to cancel these out. We need a carrier. Technically, they go into each other one time. So this just becomes 1/4 with the 4 on the bottom. And here the 4's cancel out. They go into each other one time. So this becomes plus 1 over x. So dividing by a single term is not really too hard to do. You know, it's kind of fairly easy to do. Here's a little bit more complicated problem, but still not too hard. 8x to the 4th, y to the 5th, minus 3x to the 3rd, y to the 4th. The hardest part is making sure you copy it correctly. Plus 5x squared, y cubed. And we want to divide this whole thing by x squared, y cubed. And we can put this whole thing in a parentheses if you want to, but we're not going to. So we're going to just put this term, x squared, y cubed, as the denominator for each term. And if you do it this way, it's quite easy. A little bit of writing, that's all. So now you can just divide, and there's really nothing to divide into the whole numbers, so they stay. And 4 take away 2 is 2. 5 take away 3 is 2. Minus. Bring down to 3. 3 take away 2 is 1. Don't need to write it. 4 take away 3 is 1. Don't need to write it. Plus, bring down to 5, or you could think 1 into 5. 2 take away 2 is 0. So anything to the 0 power is 1. Or we could say these simply cancel each other off. And same thing happens here. And it's just 5. Now, you don't have to factor it or do anything else to it. They just asked you to divide it. You did. You're done. So that's how you divide by a monomial. Well, sometimes we have to divide something by a binomial. So this gets a little bit tougher. Here we have x plus 3 into x squared plus 5x plus 8. So it's kind of like, let's take a look at a simple problem. Suppose we wanted to divide 3 into, I don't know, 261. Okay, the first thing, when you divide by long division, you divide 3 into 26, right? It goes 8 times, and where you put it is kind of important, and then you get a 24. On this problem, it's a little bit easier because what you want to do is change this x to an x squared. So you're just going to go over the first term. And so you have x here. And just like you multiplied 8 times 3, you're going to multiply x times this whole thing. So x times x is x squared, but then you're going to multiply the x times the 3, which is 3x, and you're going to put that right under your x term. So x times x is x squared, x times a plus 3 is a plus 3x. Then what did you do here? We subtracted 2 times. So we subtract. Well, we do the same thing here, except what we want to do, which is a very important thing, when we subtract in algebra, we want to change these signs from positive to negative. And you want to make sure that you change those signs. You don't have to use the red pen per se. So this is x squared minus x squared, zeros out. 5x minus 3x is 2x. Then just like here, you bring down, here you bring down to plus 8. Okay, then you start over again. So 3 went into 27 7 times, and then you multiply. X plus 3 goes into this, x times, maybe even a little bit bigger, because we need this term, when you multiply, should be identical to what's here. So I'm going to bring up the plus sign, whatever sign was in front of the 2, and I'm going to bring up the 2, because 2 times x, I'm not going to put an x, because 2 times x is 2x. I'm multiplying 2 times this x. And then I'm multiplying the 2 times the 3 plus 6. Now I'm going to change my signs. Maybe that's kind of a big thing. I try to make so it won't be quite as big. Change the sign. See, now they're opposite and they're going to cancel. This was plus, now it's negative. Sometimes when you change the sign, it could become positive. So these two cancel off, and 8 take away 6 is 2. And when you have something like that, we call that the remainder, and you just write it as remainder 2. See, it didn't go in there evenly. And if we did a FOIL on this thing, you would not end up with an 8 there. You'd end up with a 6, and then you'd have to add 2 more to it to make the 8. So it's kind of a little weird, okay? Let's try another one and see if we can do it. We'll just try one more. An important thing is that you can't have any missing terms. This is also important. In fact, I'm going to grab a problem out of your actual worksheet here, homework here. I'm going to try this number 13. You have, I'm going to write it up here, 4y, and I'm going to slide the paper up here so you can see it. I have 4y cubed plus 6y squared plus 14. And I want to divide that by 2y plus 4. So this one looks a little bit harder than what we did, but not super hard. But no missing terms. So I show you what we do. First of all, we're going to write down the 2y plus 4 divided into 4y cubed. Make sure these are in descending order, which they are. Make them, and this should be in descending order too. Plus 6y squared, but we need a y term. You can't jump from y squared to a number. So we're just going to put a 0, kind of like a space holder, and then 14. There we go. So now we're going to divide. And to get a 4, we need to multiply this by 2. 2 times 2 would give me the 4. And I need a y cubed. And so I'm going to use a y squared. So in some ways, it's easier than regular long division, because you want to match up these things exactly, and you don't have to worry about where you put it. You always put it over the first term. So 2 times 2y would be 4y and y squared times y is y cubed. And then 2y squared times 4, we're timesing these two terms together. This and this gives me 8y squared. Okay, we're going to change the signs. Change, change. And so these will have, I mean, the reason we change them is so this cancels out, but we also have to change this sign. So 6 plus a negative 8 is a negative 2. And we don't do anything to the variables. They still stay y squared. You can bring the whole thing down, or you can bring just one term it down. I'm going to bring the whole thing down. That way we're kind of just looking at this part. Okay, so what I'm concerned about is getting this 2y to look like a negative 2y squared. So I just need a negative to make the negative, and I already got the 2, so all I need is a 1, and I need a y. So 1y times negative 1y times a positive 2 is a negative 2y squared. A negative 1y times 4 is a negative 4y. Change, change. So we're going to change this. I'm going to just do it right here with this pen. Change becomes plus, change becomes plus. So I change those signs. Very important. Cancels. 4y squared, 4y plus 15. So to make this a 14, I should say. So to make this a 4y, I need to multiply this by 2. And you can kind of see there should be order here. Y squared, y, no y. So just 2 times this, which should work. 4y, and then 2 times the 4 plus 8. So I'm multiplying just the last term here times that, distributing it, and it was a plus. And now I'm going to change signs, change, change, because it's very important. Sometimes you forget on the last one, and then you get the wrong remainder. This should be 6, not 22. So this is a remainder 6. Now, I had a problem like this where I had a 2y plus 4. You almost have to do it by long division like this. You know, you'd like to get around it, but you really have to kind of do long division, and you got to practice maybe some of those to get better at it. But on this type of problem, where we just have like an x plus 3 or an x plus 7, we can do that by another method called synthetic division, and it's much faster. So I'm going to take this paper, I'm going to move it over here. I'm going to do this problem right here by something we call synthetic division. And you're going to like this because it's a lot easier than doing the long division. Okay, what we're going to do is, again, no terms can be missing. We're going to take this number and write it down without the variables. So we're going to write down a 1, a 5, and a negative 8. That's all we're writing down. This is called synthetic, not polyester, synthetic division. You think they would have named it polyester or something like that. I don't know. Anyhow, then we're going to put this in kind of what looks a little bit like a division thing. But right here, we have to be kind of careful because we can't use an x plus 3. So what I do, that always works, is I take this x plus 3, I set it equal to 0, I move the 3 to the other side, x is negative 3. This has to be written as a factor or as a number, okay? So I can't just put a plus 3 here. I've got to set that equal to 0 unless they gave us this number. If they don't give us that number, we have to write this as a negative 3. Or you might remember it's always the opposite of what you had there. Okay, but if you put a plus 3, it won't give you the right answer. So step 1, bring down. Bing. Step 2, multiply the negative 3 times the 1 and write it here, -3. Now calculate. And the nice thing about this is because you rewrote it here, you don't have to change the signs like we were doing on this problem where we had to change those signs all the time. It makes it a lot easier. So we're going to bring that down. We can just calculate that. That's a 2. And we're going to bring the next number. Let's see. And we're just going to leave it there, the 2. All right. Now we're going to multiply the -3 times the 2. -3 times 2 is -6. And we're going to write it over here. -2 times -3 is a -6. This original problem was a +8. I wrote it wrong. This should have been a +8. I copied it wrong. So this is still a -6. I'm going to write it here. But I was wondering why I had got a different answer and I had copied the problem wrong. So very important. And -6 from 8 is 2. Now this last number is my remainder. If it comes out 0, it means you don't have any remainder. But you're saying, well, I don't get it because that doesn't look like what I had. Okay, so this is the number 2, and the next number up would be x. So this is 1x. This is a +2 plus 2, remainder 2. So if you're just using 2 numbers here, this would be your x, and this would be a 2. We put in it's always 1 power smaller than what you started out with. You started out with an x squared. This should be an x. It's 1 power smaller. So this is 1x, and they should be in descending order, +2, remainder 2. All right, we'll try another one. I know there's a little strange one you start out with. Let's try this one. This is 25 on page 314. Okay, you've got x. I'm going to put it in the right form right away. Well, I just write it down. Okay, there's my problem. And I want to divide that by x minus 2. And it's written kind of like this in the book. Okay, so what I'm going to do is, first of all, is I'm going to write all these just the way they are, just the coefficients. 1, -7, -13, 3. Your first term is going to be an x squared term, see? And then I'm going to take this and set it equal to 0 and just bring the 2 to the other side, add a +2 to both sides, x is 2. And that's my divisor, not -2, 2. And now I'm ready to divide synthetically. Okay, what was the first step? The first step is always bring down. Multiply, write it down. Calculate. Multiply, write it down. Calculate. Negative plus negative stays negative. Multiply, write it down, calculate. Didn't look like this one went in any too easy, huh? This first term is going to be 1 power smaller, so this is going to be 1x squared, descending, minus 5x, minus 23, ran out of numbers, remainder, -43. Box it off. And there you got it. Divided synthetically. Okay. Let's try one more. They're sort of fun to do, actually. They're not, because they aren't super hard. Okay, here's another one. I think we did this one. No, it's similar to one we did. Okay, let's try this one. This is y cubed plus 3y plus 10 divided by, they don't always have to have a remainder, by the way. They can come out evenly too, by y minus 2. Need a missing term here. What term is missing? The squared term. So I'll keep that in mind. Okay, this is 1. I'm missing the square term. That's a 0. I've got a y and I've got a 10. And this is y minus 2 is 0. Bring over to 2. Y is 2. My divisor is 2. Bring down, calculate, multiply, and then calculate. Now I'm going to take the 2 times the 2, not times the 1 anymore. 4. Add it to the 3, 7. Multiply, 2 times the 7, 14. Add it to the 10, 24. Answer, y squared, 1 power less than that, plus 2y plus 7, remainder 24. Well, let's see if it works if we do it by long division. I might run out of room. I should have probably used a new sheet of paper. And if we do it by long division, we still have to put the 0 there. And I'm going to do this kind of fast so that I don't extend this too far. All right, make sure I copied it, y cubed. Okay, so I'm going to start out with a y squared times y cubed, y squared times -2, -2y squared. Change signs, change, 2y squared plus 3y plus 10. Divide, plus 2y, 2y times y, 2y squared, minus 4y. Change the signs, 7y plus 10. 7 times y, 7y, minus 14. Change the signs, 24, remainder. See, it comes out the same. You can do it this way. I mean, there's nothing wrong with doing it this way. It's just that it's a little bit faster. Bring down, multiply, write it down, calculate. Multiply, write it down, calculate. Multiply, write it down, calculate. All right. Hopefully this helps, and make sure you try some of those problems. They aren't, they kind of look scary, but they're not as bad as they seem.